This is a video about the functional groups, yeah.
Functional groups are groups of atoms attached to a carbon skeleton. They have multiple properties, and those properties are consistent.
Second video.
The functional groups are the hydroxyl group, the carbonyl group, the carboxyl group, the amino group, the sulfohydryl group, and the phosphate group.
Inquiring minds would like to know about hydroxyl groups. So, hydroxyl groups are my books over there. So, I don't know what they are.
Amory, we need the book.
Because Amory has the book. Alright. Structurally, they are a hydrogen atom bonded to an oxygen atom, which in turn, bonds the carbon skeleton to organic molecules. They're also alcohols, which, they're alcoholics.
It's just good to know.
They like to drink a lot. Ethanol is a great example of this, because it's an alcohol.
Except for they don't literally.
Yeah. Isn't ethanol gas? Yeah, maybe. Who knows? Not me. Anyway, they're polar, which is good to know. And that means that they result in an electronegative oxygen atom drawing. Yeah. Sure. They attract water molecules and dissolve organic compounds such as sugars. So, hydroxyl group. What?
Okay.
Carbonyl groups.
The carbonyl group consists of a carbon atom joined to an oxygen atom by a double bond. It's like a C and then two lines going to an O. And
kind of like this thing.
Oh, yeah.
Yeah. Cool, huh?
Okay. The compounds are ketones and aldehydes. An example of these are acetone, which is a ketone, and propanol, which is an aldehyde.
So they want to know what's a ketone and what's an aldehyde. Can you aldehyde or whatever?
A ketone is if the carbonyl group is within a carbon skeleton.
Oh, that makes sense.
Like this.
Like that. Awesome sauce. Okay. And
then
what about
aldehydes?
Yeah.
Aldehydes happen if the carbonyl group is at the end of the carbon skeleton.
Like this.
Like that.
No way.
Yes way. Okay. Their properties are a ketone and an aldehyde may be structural isomers with different properties, which means they have different properties, as in the case for acetone and propanol.
Carboxyl group is our next group. And when an oxygen atom is double bonded to a carbon atom and then they're bonded to a hydroxyl group, that's a carboxyl group. So it looks like this thing right here. Woo! Yay! They're named carboxyl acids. That's cool to know. So yeah, they're acids. What are you doing? That records on there. Child. Acetic acid?
Acetic, I don't know. Yeah.
Okay. It's vinegar. It gives vinegar its sour taste. That's an example of...
Vinegar is yucky.
Vinegar is yucky. Ew, vinegar. Gross. Well, nobody likes you. So, functional properties. Everybody wants to know about functional properties.
Obviously.
Yeah. So, it's also polar, like the hydroxyl group. Obviously, because it has a hydroxyl group in it, so must be polar. A cell found in cells, it's found in the ionic form, which is called a carboxylate group, and it's acidic. It's an acid. Woo! Acids.
Yay, acids.
Woo! Carboxyl group. Carboxylic acids. This is still part of the carboxyl group, but I wanted to talk a little bit more about the acids before we moved on to the next group. So they donate a positive hydrogen, which is what makes it acidic. And the acids are weak and organic. And organic means that they come from carbon. So they're really like carbon acids, which is kind of cool to know. Amino groups.
The amino group NH2 consists of a nitrogen atom bonded to 2 hydrogen atoms and
Yeah.
to carbon
Right
to the carbon skeleton.
The carbon skeleton. That's good to know. That means there's carbon in there.
Carbon skeleton.
Carbon! And she's gonna walk away, so I will take over. Amines. Their amines. That's their little compound name. Glycogen. Yeah, it's an example. You know how that is. They're bases. They act as bases, which is really kind of confusing because amino acids are not bases. But it says it's a base, so it's a base. They have a charge of 1+ under cellular conditions. So in the cell, they're charged positively. Yeah, I think I read everything. So, yeah.
So, the sulfhydryl group consists of a sulfur atom bonded to an atom of hydrogen.
Like this little baby right here.
It resembles a hydroxyl group in its shape.
Yeah.
The compounds are thiols. And an example of this is ethanethyl.
Ethanethyl. That
And
kind of sounds like a kid with a lisp. Ethanethyl. If you say it fast.
Ethanethyl.
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 Okay. The functional properties. 2 sulfhydryl groups can interact to help stabilize a protein structure. See figure 5.20 if you have any more questions. That's in the AP edition, Biology, 7th edition, Campbell and Reese book.
Yeah, so that probably won't apply to you.
No.
But that's okay.
Bio 2.
Finally, but not lastly, or finally, but not leastly. Well, I don't know. It's the last one, and I'm going to tell you about it. It's a phosphate group, and it is a phosphorus atom bonded to 4 oxygen atoms, and it looks like this puppy right here. Yeah. Those oxygen atoms, 3 of them, these 3 are down here, those are negative. Negatively charged. Actually, that one's not. Just kidding. These 2 of them are negatively charged. These 2 are not charged. And this one right here has a double bond. Because double bonds are cool. Anyway. These are also organic, which means they're based around carbon. Carbon phosphates. What? In addition to all of that, glycerol phosphate is a great example of this. It's got the, phosphate group at the end, all that stuff. Functional properties. Everybody wants to know about the functional properties. It's the most important part. Why do they exist? Because they have functional properties. Negatively charged. They're negatively charged. Remember that. No charge. It's a bad charge. It's negative. No, it's not 0. It's less than 0. It's negative.
I knew that.
Yeah. So. And it can transfer energy between organic molecules. So it can transfer energy between carbon molecules because organic means carbon.
Yeah, it does. We just got the thumbs up from Miss Stompy.
Yeah. All right. Turns out there's actually one more group that's not in our book, and it's called the methyl group. So Alyssa's going to tell you about the methyl group real quick because we're slackers and we didn't notice that there was a 7th group. So, Alyssa, how about those methyl groups?
Yeah, those methyl groups. Well, it looks like it's 3 hydrogens connected to a carbon. See? Circle, circle, circle.
Yay.
Okay. The compounds are methylated compounds. An example of this is 5-methylcitidine. It's a component of DNA that has been modified by addition of the methyl group.
Yay, you can read!
Yeah. The functional properties. Addition of a methyl group to DNA or to molecules bound to DNA affects expression of genes. What are you doing, Amori? Arrangement of methyl groups in male and female sex hormones affects their shape. Bow, chicka, wow, wow.
All right. This has been a Crystal, Alyssa, and Amory production.
What?